Welcome to the weekend Bucky call for February 22nd, 23rd. Although everybody that's on this particular recording is February 22nd, and all the people who are on the 23rd are not here tonight, which is sad. But we'll continue. We hope they listen to the recording. Joe, how are you feeling, and what is your expectation for tonight as we jump into a fuller explanation?
I'm feeling pretty good actually. I had a pretty good day. I was able to spend some time with friends and I'm looking forward to this evening. Uh, I think that we were kind of getting into the minutia a little bit last week about the Cuba octahedron. And I think we'll kind of continue to down that journey, as well as kind of just thinking about understanding the vector equilibrium a little bit more deeply, which is actually connecting directly with our Wednesday conversations. So, uh, yeah, no, I mean, I look forward to these conversations, and I think that they've yielded quite a bit. And I'll pass it on to Richard. How do you feel, and what do you look to take away from today?
Well, as I said a few minutes ago, feeling pretty good. And I came off a nice World Weavers discussion this morning. And earlier this week, or was last week, anyway, I was talking with some former, or not former colleagues. One was a former student, one was a new colleague, but they're very actively involved in kind of simulation sort of work and training. And so I was able to get a look at some of her work. And then I was comparing that with work that we were doing with the Johns Hopkins Applied Physics Lab back in the early 2000s to come up with a virtual training program to complement what you would learn on the ground or in the classroom. And so this morning we were talking about like AI, but Mark Weigman is quite involved with what's being referred to as, if I got it right, active inference.
Yeah,
And
you're right.
and he's sort of making the case that this is going to be better than the standard kind of artificial intelligence that's being developed. So I got kind of excited about the possibility of that being a huge advancement over the last 25 years on what the Applied Physics Lab at Johns Hopkins was doing, and that there could be some really leading edge simulation work that might arise out of their work. That's how I was seeing it in a practical sense. So yeah, it's been a good day so far, and looking forward to our dialogue. And
Yeah,
so,
actually, interestingly enough, I actually lived right by the APL and knew a lot of those guys back in the early 2000s.
oh,
Uh,
really?
yeah, absolutely.
Um,
And down
right,
in
right by them, you mean like across the
Baltimore,
street type of thing in Baltimore?
Baltimore.
Oh,
Yeah. So yeah, right. I was on Calvert Street. So, but I actually knew about them anyway. They were actually doing some work with some of the people that I was actually consulting with.
yeah. Well, they one of the things they were doing back then was they were working with the FBI and
Hmm.
doing.
They were doing more than that.
Oh yeah, yeah. But they were this particular one. They were training FBI agents to be able to spot or identify deception, mostly in sort of white collar situations.
Hmm.
Um, and so, and it was based on the principle of classroom teaching, and then you would have a virtual training for reinforcement and retention. So we we were building our model off the same idea of learn in the classroom first and then have a virtual training. And we had our virtual client who was programmed in such a way that he could remember what it was that you asked him or he told you, and if you asked the same question too many times, he'd get annoyed with you and tell you that you haven't been listening very well because I already told you that 3 times. And he'd actually get to a point where if you were actually making too many mistakes, um, he would again get upset with you and then actually just quit and walk out on you. So um, it was pretty close to a real life situation. Um, and and this one of the spin-off guys from the lab, his name was oh, blocking out now. His last name was Olson, and he left the APL and set up an organization called Simmersion, with SIM and caps and the rest of the word. So it was a simulation kind of immersion, I guess, is what he was talking about. Oh, that's neat. Yeah, that's always neat to get connections like that. Yeah. And over to you, Steve.
Okay, I'll go. Um, I'm real excited today. I had a major epiphany last week, about the twisted cube octahedron. How you could take that cube octahedron, just twist it one thing, and it would suddenly, instead of having square, triangle, square, triangle, square, triangle, square, triangle, it would have triangle, triangle, square, square.
Yeah.
That blew me away. And then the idea that there are three great circles, the equator, and then and that you could take that thing and twist it around and go back and forth between the cube octahedron and the twisted um, cube octahedron. In fact, just for the sake of the recording and for the joy of life, I think what I'm going to do is I'm going to share the actual reading we're doing. Oh, that's not the reading. I was all ready for an alternative conversation today because I wasn't clear that anybody else was going to show up. There it is right there. This is the twisted cube octahedron.
Mm.
Isn't that powerful? I don't know. To me, that was just such a huge epiphany. VE results. So it's on the previous page, the top of that page. Right there you go. Wow, that is just so cool to me. And then the other big epiphany was the fact that if you, out of all the polyhedra on the entire planet, if one sets up a rule so that you can have any angle, but all the radials stay the same, you end up with a cube octahedron. This is so profound to me, it just boggles my mind. So suddenly the cube octahedron came to life for me. And I'm looking to continue that conversation. And I'm still just jumping for joy and gasping for air as I contemplate possibility. I just don't even know what that means, except it's just profound. So I'm excited. And I almost understood everything that you and Richard were talking about APL. I almost understood that. And I was real privileged. I noticed that as far as AI goes, because Richard, you said something about AI and APL and some correlation thing. It has dawned on me that, coming back to a rule we read, I think in this book, fuller explanation, but maybe, and I could do a search on it to find out, but it was reinforced by Richard Dawkins' statement that if you found an animal, if an alien came and just landed on a spaceship and sucked up a dead animal, that by studying the architecture, the biology of that animal, you could know exactly the macrocosm that that microcosm came out of. Because
Hmm.
all the elements that are in the microcosm are in the macrocosm and vice versa. And that blew me away. And it's also come as I've pondered that, I've come to the thought that AI will never be conscious. Because, well, maybe it could be because it's in a conscious, it was invented in a conscious macrocosm. But if it is conscious, it's because the macrocosm is conscious. In other
Right.
words, you can't, you don't get that bird that you found, that the alien found, is only as conscious as the environment allows it to be, but it's the environment that has the consciousness what the bird is using. I don't know, somehow that's kind of resonating in me, and I'm kind of spinning around with it. The universe is conscious in the first place, so consciousness is not something that's emergent from some biological artifact like the brain. So anyway, I'm pondering those things. And somehow I think that our study here in this book has to do with it. And I like the Lafert's book. I think it's a really fun book with a lot of graphics, but boy, am I really grateful for, although there are a couple things I have issues with, I really like what we're learning here from Amy Edmondson. I think this is profound that we're studying this,
Oh,
and I'm really grateful for it. Did you have a comment there, Joe?
no, I agree, like wholeheartedly, like Amy's ability
Yeah.
to articulate Flora's ideas,
So I'm going to pass it to you, Joe. So how do you feel, and what are your anticipations for today, expectations for today? Have you already gone? I don't think
yeah,
so.
yeah,
Oh, you did go?
yeah, I did go.
Oh, okay, good. Well,
Sorry.
see, there you go. But anyway, if you want to comment on that, then I didn't mean to interrupt you.
Yeah.
I'm good.
Well, going back to the APL though, if the virtual guy that we were working with would have said something to you, Steve,
Oh, really?
yeah, would have said, wake up. I've already given it. And so,
I've already given what?
As above, so below.
Oh,
yeah. Well, that was
Essentially,
it.
that's what he's
That was a
going
neat,
down.
neat thing that they had programmed into the virtual client
uh-huh,
that he could remember things that you had said, and if
uh-huh.
you, or it was really he could remember what you asked him. So if
Yeah,
you asked him something about his family and he told you about the family makeup or something about his father or mother or something like
sure.
that, and then asked basically the same question 5 minutes, 10 minutes down
Yeah,
into the interview,
yeah,
he would have remembered that and said, "Hey, dude, you already asked me that question and I answered it."
Yeah.
yeah.
So,
No,
what was the
I'm,
implication of that, Richard?
Huh?
What was the implication?
Well, the implication was how well you're listening.
yeah.
So that's
Well,
it. Yeah.
and so I'm convinced that the future of AI is in agents.
Right.
And since brains are great on storing data, and since AI is based on large language models of stored data, and the AI is only as good as the stored data, I imagine there can be some synergistic put together that comes of out of an AI. And there might even be able, like Elon Musk with Grok 3, is building into it some kind of a value system to say whether a thing is true or whether it's good
Yeah.
or bad based on how it relates to whether it's true. I think human I think that's where we've got it. I think the ultimate test of consciousness is that I can know good and evil. Now, AI may better do a better job of it than I do,
Yeah.
but
No,
but
I
ultimately, that's the one thing humans have. They have that
Well,
connection to all truth.
and actually, it's interesting you brought that up because it's like actually focused on first principles,
Yeah,
like Grok is, and actually that's one of the ways it's actually validating its information against reality.
yeah. Have you saw that? I think I stuck the
Yeah,
Grok 3 video out for everybody to see. It's
it's
freaking
pretty
amazing.
impressive. I tried it. It is impressive. I mean, it really is the best one that I've seen yet.
Wow. I could throw up the chart that they used in that presentation, but it's just a chart. I got to tell you, I have every day I pray that Elon sticks to his gun, sticks to his principles, his first principles. I
Right.
hope he doesn't get corrupted or swayed in the environment that he's in. And
He already is, I think.
I don't think so. And I think Manu shared on our WhatsApp a video of Elon, but it was AI. It wasn't Elon.
Right.
Mm,
And I knew it wasn't Elon because I've been listening to Elon for 10 years. I know the guy.
right.
Now I could be tricked. He could be in a situation where suddenly he's lost his integrity, but he's Ben Franklin reincarnated as far as I'm concerned. And if he can't make it through the swamp, then no one can make it through the swamp. We're doomed. That's my. Oh, I'm sorry to be so political. I apologize. But so remember, Trump is the one who suggested that Canada be the 51st state, not Elon. Elon's not that crazy. Okay,
No.
good. Any other comments or questions? I
It-
hate to add on my editorial. Anybody else want to quickly editorialize and clear the space?
Well, my big worry about him
Yeah,
is his genes, his heritage
yeah,
as an Afrikaner.
yeah.
He comes out of a long history of white supremacy,
Yeah,
and
and if you heard his conversation to the world leaders, where he talked about Germany and how they need to be proud of their heritage and they need to stick to their museums and make sure everybody knows, but the atrocities that one German guy led the country into should not cancel out all the great things that German culture has done. And I think he's just got his eyes wide open. Oh, I was going to let you get the last statement, so I'm going to quit again. So are you complete, Richard?
oh yeah, and I'm just uh, expressing my worry as far as his genetics are concerned,
Yeah.
um,
Well, be careful.
and I heard something today that was interesting too, which didn't isn't necessarily directly related to him, but of the all the people who have been, in a sense, unceremoniously deported already. Um, a large percentage of them are all black and brown.
Well, yeah, they're immigrants. They're immigrants from other countries. Listen,
Yeah,
I
yeah,
share with you that
but
there's a tragedy going on.
immigrants from other countries include uh, the
Oh, white
Caucasian.
people as well. Yeah, include white people as well. Hopefully, they're all criminals. And I don't know why. I want to let you have the last
I
statement.
I think that is just such um, a non-starter to use this. I hope they're all criminals, um,
Yeah.
because they're also able to make up fairly quickly something that would um, make you a criminal.
Oh, absolutely. They came from environments where that could possibly be the only.
Actually, that reminds me, Richard, you never sent me the name of the individual that wrote the letters to people in prison. I had asked you for that a long time ago. That there was a program where they had actually written letters to individuals in prison about telling their story. So that,
Oh yeah, well that was, yeah. My apologies on that. That the
yeah, that's something actionable.
her name is Lisa Kenner, and she's the youngest daughter of Hugh Kenner, who was Bucky's first biographer.
Hmm. Yeah. Could you
And
send
she,
me that?
yeah, I'll send it to you. I've
Yeah, that was about 8 months ago. Yeah.
yeah, it's an organization called Context Con, meaning prisoner,
Right.
textos, meaning writing. So it's a play on words, and they spend a lot of time teaching them how to write their own story.
Yeah, just send me that whenever you have a minute.
Yeah.
All right. Okay, and here we go. Wonderful. We're starting today on page 105, VE results. And I do like it when we trade off some reading. I'll go ahead and start, pass the ball along. It's easy to forget to pass the ball along. VE results, our first encounter with the vector equilibrium in chapter 4, then we called it the cube octahedron, illuminated its direct relationship to the octahedron and the cube. 8 radiating tetrahedra alternate with 6 1/2 octahedra. We now elaborate on our description of the VE, and before the end of this investigation, we will know almost everything about this extremely important shape. Let's begin here with its major characteristics. Above all, it is the omnidirectional arrangement of forces. This equivalence is unique to the VE. Well, that's interesting. I'm wondering what that is. I think it has to do with all the radii. Secondly, this shape bears an interesting relationship to other familiar polyhedra. Its 12 radii form 8 symmetrically arrayed regular tetrahedra, corresponding to the VE's 8 triangular faces. Figure 7.7 emphasizes the tetrahedra, which radiate outward edge to edge. Okay, which radiate outward edge to edge, creating 6 cavities in the shape of square-based pyramids. Again, because the uniform edge lengths everywhere, these cavities, because of the uniform edge lengths everywhere, these cavities are actually perfect 1/2 octahedra, corresponding to the 6 square faces of the VE, which in turn correspond to the 6 faces of the cube as revealed by the degenerate truncation in chapter 4. I wonder if it would be good to look at that thing again. So there is the octahedra, and
Yeah.
there's the triangular faces. Thirdly, the pattern of this nuclear equilibrium discloses 4 hexagonal planes, symmetrically interacting and symmetrically arrayed around the nuclear center.
Yeah.
You know, when most people visualize a three-dimensional space, they see a cube, but in order to, okay, I'm not going to say that. Some of the cubes, some of those lines are made up. They have to imagine something out there, where there's nothing to imagine in the cube octahedron, in the vector equilibrium. It's all there. I don't know
Yeah,
if
well,
that
one
means
of
anything.
the interesting things here for me is when you say the the square-based cavities, equal half an octahedron, and you talk about the triangle um, based cavities, you have octahedrons, and those and the you get both of those shapes by the radii that go into the center
Right,
off of the square
Right.
face or the triangle face.
right.
That image above actually demonstrated that well.
Yeah. And that's like what I was saying last week about the young boy, 8 or 9 years old, that um, solved the puzzle that I gave everybody who visited our exhibit at the university. Only it was an exercise I got from somewhere from Fuller's work, but it was the idea that you've got 13 gumballs and as many toothpicks as you need, and your challenge is to build um, uh, independent cavities. I would use the word cavity now, but independent cavities to house 20 people. And it turns out um, it's the icosahedron that connects into all all of the all the radii connect into the to that center point. That's the 13th gumball.
Beautiful.
Hmm.
And I just realized something. Joe, you invited me to kind of turn back here. This cube octahedron is made just from tetrahedra.
Right.
Notice that there isn't a line connecting this corner to this corner. These are just tetrahedra floating in space. And if we could see, there'd be space between every one of these tetrahedra, and the result would be these empty spaces that create the half of the octahedron. So that was cool. I'm glad we went back there. Any other comments or questions?
Yeah.
If you look closely at figure 7.8, which is coming up on the next page, I'm going to show you figure 7.8. There it is, 7.8. Here are the great circles I was talking about, represented by different dotted lines on the double line.
Hmm.
4 hexagonal cross section of the VE.
Yeah, you can see that.
If you look closely at figure 7.8, the 4 hexagons are clearly visible, one parallel to the horizon, one in the plane of the page, 2 or more, and 2 more slanted to the right and to the left at 60 degrees to the horizon. As we might have expected, the vector equilibrium consists in a way exclusively of hexagons. The symmetrical properties of hexagons with respect to the plane are evident. Refer back to figure 7.4. And so the discovery of intersecting hexagons in a spatial equilibrium of vectors is not surprising. So I'm ready to go back to figure 7.4. 7.6, 7.5,
Hmm.
7.4. Yeah, these were the resulting hexagons. And I have to say that I didn't particularly understand this thing. They were talking about putting vectors head to head and how they were not stable. And if you crisscrossed them at 90 degrees, somehow they were stable. And here's the square root of 2, which is a squared, or a plus b equals the square root of 2, which is the Pythagorean theorem. And then here are the things. So I never really understood that.
Yeah. I mean, that was actually interesting. One of the videos that Richard was playing last week covered that well.
Okay. However, the intuition cannot as easily predict the number of hexagons. An array of equivalent vectors, taking into consideration both magnitude and angular orientation, is achieved by exactly 4 evenly spaced intersecting hexagons. Thus, the existence of 4 fundamental planar directions or dimensions describes one aspect of the inherent shape of space. Well, I wish I could see an animation of this. An array of equivalent vectors taking into consideration both magnitude and angular orientation, so they'd have to be the same size and the same angle, is achieved by exactly 4 evenly spaced intersecting hexagons.
Hmm.
Okay, I think I got that. I think I got an invitation to understand that. These hexagons are exactly parallel to the 4 faces of the tetrahedron. Having the same angular orientation, they are identical mathematical planes. The only difference is that the VE they intersect is a common center, while in the minimum system, they together enclose
Closed
space.
space. Yeah.
Yeah. Also fascinating is the fact that each of the 12 radiating vectors is perfectly aligned with an opposite vector, exactly 180 degrees apart. Thus, the 12 can be seen as 6 intersecting lines with a positive and negative direction. I had a big epiphany on positive and negative in the paper I wrote on the 4 dimensions, which is the same as taking the X, Y, Z normal 3-dimensional graph. And if you're going to show a cube over here in the upper right-hand corner, then you should show a cube in the lower left-hand corner, which would be a negative cube because they exist. If one exists, then so does the other. There's a positive one and a negative one. Also fascinating is the fact that each of the 12 radiating vectors is perfectly aligned with the opposite vector, exactly 180 degrees apart. Thus, the 12 can be seen as 6 intersecting lines with a positive and negative direction, each line twice the length of the original unit vector. Just as the XYZ axis are 3 lines intersecting to define 6 directions, 3 positive and 3 negative, evenly spaced with intervening angles of 90 degrees, which is basically what I said, which is wonderful. Once again, these 6 intersecting lines are parallel to the tetrahedron's edges. It was not at all obvious from our initial requirements for a vector equilibrium display that the resulting radial lines would be collinear pairs, nor were these 6 double-length vectors would each lie in the same plane as 2 others, producing precisely 4 defined hexagons. Well, I get that what I was saying I doubted before, I get it right there. There are 6 double-length vectors. Each of them lie in the same plane as 2 others, producing 4 precisely defined hexagons. I got that. And here's figure 7-8, 4 hexagonal cross sections of VE. 1, 2, 3. I don't see the fourth one. 1, 2, 3, and 4.
The fourth one is
all around.
Right.
Yeah.
Yeah, it's all around. It's a
It's
solid
interesting,
line.
actually, when I look at that, I mean, this is somewhat comical, but I don't know if you remember Star Trek and the little kind of communicators that they had on their chests. It's like 2 of those.
Yeah.
I had to say it.
Did you just see the notice that came in from Ann?
No. Oh, earlier today, you mean?
No, just 2 seconds ago.
No, I didn't see it. What's the word?
You should get it there, but I don't see it in front of me now. But it was something about she said one of our little 5-year-olds has made it into the finals or something of the
Wonderful.
competition.
Wow.
A 7-year-old made it into the top 5 finalists existing business category against the other finalists who are older than teenagers. Wow.
Wow.
So 7-year-old actually made it into the top 5.
Wow.
Yeah.
Beautiful, beautiful. Congratulations, Anne. Oh my gosh, it's so wonderful to see who's participating in these calls. It just really is a privilege to be here. I'm going to finish this last paragraph. Our goal was to create a radial display of evenly spaced unit vectors. In so doing, we arrive at 2 fundamental observations about the order inherent in space: the existence of 4 distinct planes of symmetry and 6 linear elements. Both aspects are first exhibited in nature's choice of minimum system, and secondly reinforced by your unique equilibrium configuration. Wow, that's a mouthful right there, right?
Yeah.
It puts the tetrahedron together with the vector equilibrium and says, we got it. If you understand this, you understand the entire universe.
Well, of course, on this one too, now I can even see it better than I could see it earlier. But when you look at that 7-8 and think about it as a jitterbug,
Yes.
then when you push the top triangle down towards the bottom triangle,
Right.
and twist it, as
Yeah.
you were talking about, then it starts to torque down into the octahedron, and then it unfolds into the tetrahedron, and then you can lay it down in such a way that you end up with a triangle.
Right.
And
Yeah.
then it pops back up. And the reason that is so dynamic is because you've taken, I forget how many it is, but a number of the struts out of the icosahedron to give it that mobility. And for me, that the vector equilibrium moving that way, the jitterbug, is where those spotty motions come from in terms of spin and precession and orbit. And and torque and in and out and expansion and contraction.
Yeah, I mean, yeah, that's where the whole thing is headed towards, the degrees of freedom.
Yeah, I'm going to share because you just described the jitterbug. I thought it was going to, oh, there it is. Okay, good. Here we go. Um, here is your, if you restate what Richard just said, you start with the cube octahedron.
Right.
You start to squish it down. That's where you get your icosahedron with what he calls ridged diamonds, because the squares collapse into triangles that are connected by an imaginary vector that is not there normally. But then it continues to squish down into the octahedron, and then it continues to squish down into a four-bonded tetrahedron.
And then you can lay that one down and you end up with a triangle.
Mhm. Okay. Cool enough.
Yeah,
So
no, that's a really neat diagram.
yeah, I kind of stuck it together with things. As I've been studying jitterbug, I just thought it was really essential. I'm a very visual person, so we go from there. Okay, who wants to read from Degrees of Freedom? Whoops, there
Give
we
it a
go.
shot. Degrees of
Yeah,
freedom.
I'm just going to say I'm on my phone, so it's the print isn't all that large, but
I'll
The
do what I
subject of
can to
12,
enlarge the print, okay? And we'll see if it
subject
makes
of
it any
12
easier for
fundamental.
you.
The
Is that
subject
any
of
better?
yeah.
Okay, good, Richard. Wonderful. But let me get back where we're going to start. Oh, geez. Okay, here we go. Degrees of Freedom. Go ahead, Joe.
The subject of 12 fundamental directions of symmetry with their 6 natural positive and negative pairs leads directly to a discussion of the 12 degrees of freedom inherent in space. The term is almost self-descriptive, but can be explained in reverse. That is, we explore the number of degrees of freedom inherent in space and thus the effect affecting every system. In terms of how many restraining forces are necessary to complete and inhibit a system's motion,
Mm.
it's the minimum number of applied forces necessary to anchor a body in space. Again, we can start with a planar analogy. Imagine a flat circular disc, such as a coaster, lying on a table and held in place by 2 taut strings pulling in opposite directions. The disc looks stable, but actually is free to move back and forth at 90 degrees to the line of 2.
Restraints.
Restraints. So we try applying 3 tension forces 120 degrees apart and observe that the circle's position is fixed. Actually, it turns out that only the location of the exact center of the circle is fixed, for the disk is free to rotate slightly in place. Because rotation involves motion directed at 90 degrees to all 3 strings, there is nothing to restrain the circle from twisting back and forth, as shown in figure 7-9. 3 additional strings to counteract each of the original restraints would have to be added to prevent all motion, for a total of 3 positive and 3 negative vectors. And there you go. You can see that very clearly in that in that picture.
Wow, 3 positive and 3 negative vectors. 3 strings attached to that disk become 3 positive and 3 negative vectors. Interesting.
Yeah, you can see
So
it pretty clearly, actually, though.
are the circular ones the positive ones, and the straight ones the negative ones? Or are the double lines the negative ones? I'm curious. Oh, here
Um,
we go. A is restrained at 1 point, B is restrained at 3 points. Well, we got that. My question is about a total of 3 positive and 3 negative vectors. And I wonder if these curving lines here,
Well, if B is negative, I mean, then,
well,
Up and down.
yeah, you can see.
yeah, B isn't negative by its nature, but 3 additional strings to counteract each of the original restraints would have added to prevent all motion for a total of 3 positive and 3 negative. So the 3 strings make up 3 positive and 3 negative vectors.
Right, you can see, yeah.
I'm not clear as to
Whereas
what.
opposed to A is just one restrained at 1 point.
Sure, I totally got that. But
Up and down.
where are the negative vectors? Are they the double lines here, or are they the curved lines here? So I guess we'll move
I
on.
mean, I would say they're the double.
Interesting. Let's see if she explains it below. Do you want to continue?
Yeah, sure. In space, a similar procedure involves a bicycle wheel. Suppose that our goal is to anchor the hub with a minimum of spokes. At first glance, this may appear to be the same problem as the previous planar example. However, in this case, the hub has both width and length. Both circular ends and the narrow hub, typically about 1/2 inch, 13 millimeters wide and 3 inches, 76 millimeters long, must be stabilized with only 6 spokes attaching the hub to the rim. 3 fixing the position of each end, as shown in Figure 7-10.A. The system feels quite rigid. Force can be applied to the hub from any direction, up, down, back, and forth, without budging it. However, the hub has no resistance to an applied torque, the effect of which occurs at 90 degrees to the spokes and is therefore able to twist slightly about its long axis. 3 more spokes at each end to counterbalance the original 6 remove the remaining flexibility. At 12 degrees of freedom are finally accounted for. All 12 degrees of freedom are finally accounted for, with a minimum of 12 spokes. Actually, this reminds me, I mean, I don't know if you have it handy, Steve, but you actually had actually drawn a diagram that was actually pretty that demonstrated the 12 degrees of freedom pretty,
I do have that. It's the it was relative to bird murmuration.
yeah, exactly. Yeah.
Yeah, I do have that. And I'll be glad to show that in a minute. Any comments on what Joe just read? Because I just had an epiphany when Joe was reading that. If we can, I'm going to go find that thing.
Well, I mean, there is a tensegrity example there.
So go ahead and describe it.
It was the idea of where was it? The idea of rigid. Essentially, where it was saying that the idea of how there's a balance between the spokes as if they're exactly what did it say about rigidity?
I'm going to get to that because I have a question. I had an epiphany and a question about that. But here are your here are the 7 directions with bird murmuration. So with the cube octahedron, or with the octahedron as a thematic, as a structural representation of the 7 degrees of freedom, not 12. So maybe that misses the point, Joe.
Well, I think the point of that is that that center one is being is held firm, um, stable. You see, and
Right.
I think maybe what you were getting at on the earlier question of negative and positive, that you have to add three more in there to get your positive and the negative.
I see. Minimum 12 spokes needed for
And
stability.
and
A
then
is a, go ahead.
well, I was going to say the tensegrity that's in the rim and the hub of the bicycle wheel um, are if you want, the 12 spokes that are needed for stability.
Right,
That gives you your tensional sort of stability.
right on. I'm going to share something that I hope is not too much of a distraction, but coming up to this thing here, what dawned on me is that what we have here is we have a two-dimensional plane. I mean, it's obviously that disk is 3D because there's a depth there. But theoretically, you could have a thread coming out of here. This could be a 2D entity. And here's the strange epiphany I got. If it spun around, it wouldn't matter because in a two-dimensional reality, there is no third dimension. So it would be of no consequence. In a 2D reality, there is no third dimension. So it could spin around, it could be spinning around forever, and no one would, it'd be of no consequence because there's no third direction for it to fall into. I don't know if that means anything to anybody else, but it sure meant something to me as an epiphany that I was struck to. Is there any other comment on this right here? Um, I've always had a question about bike wheels. Why are these radials, why are they off to the side? Why aren't they coming out at 90 degrees from looks like it heads out
Yeah.
at 90 degrees and takes a 60-degree turn.
Right.
Well, but that's because that hub is got widths and lengths to it. It's not just a dot, if you want.
But I've noticed it on
Yeah.
bicycle wheels. I've
And
actually
look
marveled.
over at the left, you see so you've got you've got a wire coming out of one end and a wire coming out of the other end.
Hmm,
So you've got 6 and 6 probably is 12.
let's see here. I'm going to just do a quick search for bicycle wheels and see what we come up with. I hope everybody's okay with this. Google bicycle.
Think the three additional spokes that she's talking about in the text actually accounts for what we're seeing in NB.
Is it just me? But it appears to me that
And how they actually counterbalance everything.
see, these are all spinning off at an angle. You see that? None of them come out at 90 degrees. These two here appear to come out at 90 degrees, but actually they're not 90 degrees. Those two guys would be coming right out of here if they were 90 degrees. I hope you're all seeing what I'm seeing. Yeah, you're all seeing. Can you see my mouse? You can't
No,
see my mouse?
No.
Okay, but
no,
do you see how these lines, they seem to almost be parallel as they come off of the hub? Do you guys see that?
Yes.
And as they do, they're not quite parallel because they seems to be smaller at the wheel side of the hub, and they're larger at the hub side, right?
Correct.
All of them are larger at the hub side and thinner at the wheel side. None of them connect right at 90 degrees because if they did, they'd all be exactly parallel, right?
Right.
Look at this. So I've always noticed that about bike wheels, and I've always wondered why that, it's obvious for stability. Otherwise, they would do it some other way, right?
mhm.
but I don't understand it. Okay, I just thought I would. I apologize. I'm glad I get to vent and rant on this call. Thank you very much for your patience. Okay, here we go. All righty. And we finished that reading, right? Yeah. For a minimum of 12 spokes. Okay, Joe.
Okay. Sorry. All right. The experiment is quite, no, I can't say it. The experiment is quite rewarding to experience, well worth trying for yourself. You don't need to go as far as dismantling a bicycle wheel. Just find a hoop and any material and size and a short dowel as a segment, and then connect the two with radial strings added one at a time until the hub is suddenly becomes rigidly restrained. It is enormously satisfying to feel the hub become absolutely immobile, all freedom taken away, with the surprisingly low number of 12 spokes.
Okay, so there's your 12 degrees of freedom. That's a perfect analogy of 12 degrees of freedom. Now, here's what's interesting. This is only showing one side. This is only showing the positive. Is that true? Because when I showed the picture of the wheels, there were 12 on each side of there were 12 spokes on each side of the wheel. Do you guys recall that?
No, I don't think there was.
Yeah, I'm
I
going to
think
show
there's
you.
6 and 6.
Here you go. See that, you guys? There are 12 on
No,
this side and 12 on the other side. Because you guys,
but, yeah,
and
but that's different. Um, that like is she saying that all you need is those 6 and 6 in order to give it absolute stability? This has gone much further than that.
well, except you look at any of these bicycle wheels, there's more than six.
Yeah, well, that may be just to give it extra stability. I don't know. But
There seems to be fewer on this one. No?
I mean, to have that many more would give you just that extra tensional strength.
Well, I'll tell you what it does for me. If you guys, and I'm not sure I'm helpful, but do you see how these all seem to be not at 90 degrees? And the trouble with this is you have all these vectors pulling in one direction. It would end up wanting to go to 90 degrees. So you have to have them on the other side pulling in the opposite direction in
Yeah,
order to maintain that rigidity at a non 90-degree angle with
yeah.
the wheel. So there you go. I've seen some car wheels that only have three spokes, but of course they're made out of, you know, magnesium. Okay, good. So I'm ready. Don't mean to be too confusing. There was a footnote there. She attributes that comment to the minimum tensegrity wheel
Yeah.
thesis for completion for her BA requirements at Harvard. Wow,
Well,
that's cool. So she wrote a BA paper on this. Wonderful. If there are no other comments, I'm sorry for the distractions. We can
yeah.
continue, Joe.
I was looking things up myself. What both the planner and spatial procedures indicate that is that degrees of freedom are both positive and negative. And anchoring the hub of the bicycle wheel, there at first appear to be 6 degrees of freedom. However, each has a positive and a negative direction. In conclusion, degrees of freedom measure the extent of a system's mobility. How many alternative directions of motion must be impeded before the body in space is completely restrained?
Okay, before we continue, I'm going to come
Oh,
back and amend something I said. Richard, do you have something?
Well, only I guess to me there's a confusion in what is meant by degrees of freedom, um, and then having it show that when they're all in place, you have something in the middle there, the hub, immobile. It's fully restrained. It's stabilized. So I'm now back to, it's interesting. Why are they called 6 degrees or 12 degrees of freedom?
Good.
It
I
sounds
have an
like
answer.
12 degrees of constraint.
Oh, perfect. And that actually goes back to a correction. I'm going to correct what I said because Joe, when we were talking about murmuration, there
Right,
are actually there are 7 directions, but there are 6 degrees of freedom.
right.
The seventh direction is the inside direction, the
Yes.
That's
self, and the
yeah.
6 degrees of freedom are the ones rating out um, in the up direction and out in the down direction.
Yeah.
Up and down. I tried to avoid up and down, and then east, north, west, and south. So you have your the up, down, the 7 sacred directions in the Native American medicine wheel. There are your 6 degrees, but it goes in both directions. It's 6 degrees out plus 6 degrees in is 12 degrees. That's what
And
I just
it's holding the centerpiece stable.
stable. Exactly right.
It's restrained or
Yeah,
constrained.
that middle entity is not exploding
Hmm.
because if it only had vectors outward, it would be exploding. But it has
Right.
vectors out and vectors in, which help it maintain its integrity. Woo!
Hmm.
That's mind-boggling. Thank you, Richard. I hadn't thought of the exploding idea, but it's quite exciting. I know when I was a kid, I used to watch things explode.
Yeah, right.
Okay. I want to continue, Joe.
Yeah, sure.
I think we're in the box.
Yeah, sure. Fuller's use of the term degrees of freedom must be distinguished from the conventional treatment of the subject, which specifies that a rigid body has 6 degrees of freedom, be translational and 3 rotational, which have which have 2 directions each, thus requiring 12 unidirectional
Wow.
constraints.
That just blew my mind. That makes things quite different than my 7 directions, doesn't it?
Yeah, it does actually.
Wow. My mind is blown again.
There we go.
Okay. Any other comments?
Well, I
No,
mean, this is speaking to what I was just raising is that um, in order to specifies that a rigid body, which is in the middle, has 6 degrees of freedom, three translational and 3 rotational, which have 2 directions each, thus requiring 12 unidirectional constraints. So it it's again it's a playing with words. Like the constraint tells me that um, system, if you want, is stable now. Um, and then, but the degrees of freedom imply that it should be free to go. It should be not constrained. But so, and
Well, I'm going to ask this a question. What is a translational degree of freedom? Look at there, it would have done it all itself. Translational degree of freedom refers to the ability of a particle or a molecule to move freely in 3 spatial dimensions of space. So that's translational, meaning it can move along the XYZ axis. Okay, so then what is there were there were translational and there were rotational.
rotational, yeah.
Yeah, so now what are the 3 degrees of rotational? Rotational. Rotational degree refers to the number of independent ways a molecule or object can rotate around its center of mass. That's obvious. Duh. My left brain wanted to make that real
Yeah.
complicated.
So in one sense, then, if I'm thinking of the XYZ, the three translational are, up, down, over, out,
Right.
and the rotational and around.
Right. So this guy here could be spinning in three directions as well.
Yeah,
And then while he's spinning, he could move out or he could not spin and move out in any one of these other six directions,
yeah,
which are these six directions are basically a positive and negative of three directions because these are
right.
XYZ, right?
Yeah.
XYZ plus and XYZ minus.
And so the same is true when you have 12, and you got 12 or 6 plus and 6 minus.
Yeah. Wow, I think I'm understanding some of this. I don't want to be too aggressive. It's,
Well, I mean, but the murmuration one too was what we um, appreciated last week, I think it was, when we realized the indigenous wheel is the triangular face north and south and east and west.
right,
Whereas if you do it on a XYZ kind of crossing, you end up getting your north, south, east, and west are counted off the points or the corners, not the triangle faces.
right.
And then we looked up the medicine wheels and saw what I saw anyway, with most of them are the angled faces, not the um, north, south, east, west nodes or points, although they do use both.
Cool. Well, I'm learning something. Any other comments or questions?
No,
Okay.
it is interesting.
Well, what's also interesting for me on going back to the indigenous medicine wheel, that if you are using the one that has basically the cross in the middle, in other words, you turn it into four quadrants, and then when you pull the centerpiece out, if you want, then you end up getting a square-based or in this case, a round-based pyramid. Um, and and so in that sense, it's sort of like half an octahedron. Only it's got a kind of a circle. It's got a circle base to it. But if you were doing it with the triangles and pull them out, then you actually no, you don't get what I wanted. I was going to say get the tetrahedron. No, you pull where they intersect there. If you pull that out,
You pull that up like the top of a teepee.
yeah, you then get a round-based pyramid
Right.
with four triangle type faces and one round bottom.
Unless you build it with a tetrahedron. So acknowledging the black here, that would be your door on the west. Actually, most in Sioux and Lakota Indians, the door is on the east usually. And then you
Mm-hmm.
take, instead of splitting here, you just take a horizontal line down. There's your tetrahedron. And then they take 12 other poles to make the circle. So the
Right,
teepee is not a medicine wheel. The teepee is a tetrahedron.
right.
But the
Yeah,
result is you still have four directions manifesting inside.
yeah,
Yeah, actually, you have seven directions because the center of the TP is the seventh direction, and coming out to the top of the TP is the up direction, and going down into a hole is the down direction. And that's how most sweat lodges are
yeah.
built. But
And
most,
what I learned today in terms of the visual, you can take that centerpiece and pull it out, and so you get the kind of the external um, diagram or the say the sweat lodge, But if you pushed it in, then you get sort of an inner sense of the sweat lodge, and maybe that's what's going on. When you're inside, uh, you're sort of the inside of um, the sweat lodge.
Right.
Um, and when you come out, then it's like you now have the external version of it again.
Right
So
on.
so that center piece, in a sense, can move in and sort of be a soul searching experience inside, and it can come out, and it can be more of the external sort of experience.
Right on. So here's the,
Yeah,
I've studied the sweat lodge extensively,
yeah,
pondered it, meditated. Here's your sweat lodge. It has a parallel lattice going across the top, starting from each of
oh,
the cardinal directions. So here's showing east,
yeah,
and here's your parallel lattices coming up, and then parallel lattices off the south, and the east, of course, goes to the west, and the south goes to the north. Then they have usually a support lattice in between, but somebody who knows what they're doing with sweat lodges does not block the square hole in the top of the sweat lodge, because that is the gate to the up direction.
mm-hmm,
And there's a square hole here on the south, and there's a rounded square hole here because we make a door.
right,
And then you have your square hole on the west and square hole on the north. Those are square gates. Each of these are gates that allow the spirits, the guides to come through and access the person who's sitting in the center. Symbolically sits in the center. This is where the fire is, where they bring in the stones to the sweat lodge.
mm-hmm,
And those stones represent the seed of creator and the heat. In fact, there's a thing called a heart line that comes out where the fire is out here to the east. They put the rocks in, they burn they heat the rocks up, and then bring the seed in down the heart line and drop it into the center, which is like very suggestive of creation, the seed coming into the
right.
womb. And this is where each person gets to manifest their individual destiny. So there's my rant on the sweat lodge. Any other comments? Richard, you studied this too,
No,
so what did I miss?
oh no, I mean this is I mean when you see the parallels, and you also see them coming across in a spherical way as well. Um, but going back to the holes, the top hole that you don't cover up, but the
Yeah.
others are open too, are they not? Is that it? Like they let the flow of the air, so to speak, come through.
Well, it's supposed to be spiritual energy because
Yeah,
these are all hides that actually trap the heat and the steam from the rocks inside. So it's
yeah,
not it's not it's spiritually permeable, but not physically permeable in theory.
right.
Yeah. I'm going to have to examine this top hole idea now that we've talked about that, because maybe this is a hexagon up here, because when the lateral supports come through, this might be a hexagon. I'm going to have to look at that. Okay. Any other comments or questions?
No, I
No,
mean,
well, I mean the other, I don't know why the red lines are there, but I mean one shows a square and the other one shows a diamond shape.
Yeah, the red lines are the theoretical application of the four cardinal directions. The red circle is the up direction, and the red circle goes into the ground. It's the fourth direction. So the red writing represents the superpositioning of the seven directions
Oh, I see,
in the
right.
physical sweat lodge.
Hmm.
Yeah. Okay. And I see it gets a little rugged there at the top, so that's kind of weird. All righty. Joe, do you want to?
yeah, sure. Hang on. Uh, So the
The
12
12 vectors, yeah.
The 12 vectors needed to restrain a body can also be omnidirectional instead of the basically planar organization of the spoke wheel. Fuller takes us through a similar sequence in synergetics. Which starts with a ball attached to one string. The ball is free to swing around in every direction. The only restraint is on the radial sweep out distance. The ball's motion is thus free to describe a spherical domain. The addition of a second string restricts the ball to motion within a circular arc in a singular plane. A third string allows the ball to swing only back and forth in linear path. The ball can always be pushed slightly out of place no matter how taut the three strings. And just as in our search for the minimum system, a fourth event suddenly created insideness and outsideness. By adding a fourth string to the ball, its position is suddenly fixed. Four-string dimensionality again. In their most symmetrical array, the four strings go to four vertices of an imaginary tetrahedron and therefore separated by approximately 109.47, the tetrahedron's central angle, figure 711-C. But of course, that is not the end of the story. The ball is still free to twist in place. To prevent this slight rotation, three strings must be attached to each location of the original four, figure 7-11B. This result
Oh, 711D. Okay, good.
yeah, this result is related to the fact that three is a minimum number of coordinates needed to specify the location of a point in space with reference to the origin of a coordinate system. The whole picture is falling into place. Every physical body has four basic sides of four corners. 2 points alone are only collinear, and three are only coplanar. Not until there are four corners can the body must be can the no, wait a minute. Not until there are four. Is it comers? Is that
I think it's a typo.
yeah?
You're right. You read it as corners in the first place, and I think you're right.
Yeah. Can the property of spatial existence be recognized? As a result, any physical body must be held at four non-coplanar points with three restraints at each point in order to be stabilized. This result suddenly ties into the earlier discussion of pattern integrity. Triangles are necessary for stability. Therefore, while the ball was seemingly held in place by four restraints, it could still rotate locally because the locus of each individual restraint could not be stable without triangulation, subsequently provided by the addition
Sorry.
of three strings per locus.
Before you continue, I'm going to show the picture. There's this picture. In A, you have your line at the top and the bottom, the vectors at the top and the bottom, and of course the thing can swing around this way and that way. And then you bring in a third string. And then you bring in a fourth string. And then D turns into total chaos. Ball restrained by two strings, ball restrained by three strings, ball restrained by four, ball restrained by 12. But see, I don't make much sense out of this. So
Well,
anyway,
those lines coming in, it's like holding the ball in a nest.
right.
Um, and it's stable. It's really immovable. It's secure.
But D doesn't really ball restrained by 12 points. This seems to be very quick, chaotic. I don't understand. I understand these pictures fairly well. Well, I understand this picture really, really well. I understand A really well. I think I understand connecting a third point.
Yeah, and those are movements, and then the other one, the dotted lines on that one it's still pretty stable, but there is a little bit of wiggle room, which is what those dots are representing. And then the next one, when you add in some more lines, it is immovable. It's stable,
Right.
and there is no dotted lines in that graphic.
Right. And I think we left off at 3 lines per locus, right?
Correct.
Okay, cool.
Bucky explains the situation further. Consider the ball with the original 4 restraints. The strings impinging on the ball create 4 vertices without supplying the necessary 6 degrees to stabilize their position with respect to each other. They essentially form an unstable quadrilateral rather than a stable tetrahedron. The lesson is the same. There are 4 fundamental corners in every system, and each must be triangulated. 4 times 3 equals 12. Thus, there are 12 degrees of freedom tetrahedrally organized. 12 is a frequently reoccurring number in synergetics, a fundamental part of space and geometry, as we shall see again and again.
Now I get it now.
Yeah, I see.
This represents 3 vectors off of each of the 4 of the 4 directions.
But then you go back over to C, and no, wait a minute. 1, 2, 3, 4. No, that doesn't do it either. See what they were also saying. You got to, at the ends, the vertexes, they need to be connected as well. Oh, there it is. Yeah. So you take those outer points, the end of the lines, and if they're just standing there like that, you don't have a stable sort of tetrahedron. But if you have edges that connect that those 2 bottom triangles and then the triangle up to the top, you get your tetrahedron. The outside sort of points are now connected to each other, and you end up with there's 6 of them. Should be 6 altogether. You add 1, 2, 3, 4. No, 1, 2, 3, 4.
Are you talking about D right now?
He's talking
No,
about C,
I'm
I
talking
think.
about C. Yeah,
Really?
because it was an easier visual to hook the those 4 endpoints together.
Well, I'll tell you, I thought I
And so
understood
then
that.
you
Okay.
get the center point inside.
Yeah. I thought I understood the verbal description. I don't understand these graphics. I see a completely different picture here. But anyway,
Yeah.
where did we leave off? I think we left off at the top of the page again and again. Boom. So here's the drawing, and then we can continue.
A, ball restrained at 2 points. B, ball restrained 3 points. C, ball restrained at 4 points. D, restrained at 12 points. Ball restrained at 12 points. The above procedure describes Fuller's own interpretation of degrees of freedom, which must be distinguished from Loeb's analysis of the concept as briefly explained in chapter 5.
Well, that to me this is very helpful because I've been confused a little bit about the degrees of freedom and the way Bucky talks about it. Nobody ever said that there's a difference between Fuller and Loeb, and now we're hearing it, and I'm glad to see that. So that's a wonderful thing. Hey, Richard, can you see this well enough to read? Or do you want to let Joe continue?
No, I can see it now.
Okay.
So the introduction to the vector equilibrium is now complete, except for one philosophical consideration. It is important to realize that the whole discussion is about conceptual, not actual, which is interesting because it takes us back to the idea that, the map is not the
Territory.
is not the territory.
Yeah.
So conceptual is not the actual. Balance. Equilibrium, any physical form can only be approximation. No, we need to change the page.
Yeah, we're going to change it.
No matter how exactly centered the hub of the bicycle wheel seems, and no matter how tight the spokes, gravity's pull on the hub will always exert more tension on the upper spokes, leaving the lower spokes ever so slightly slack and imperceptibly curved. The balance is imperfect. Moreover, energetic motion never ceases. The air molecules in the living room do not stop their vigorous motion once the temperature is consistent. The floor and fallen object press together in a persistent dynamic exchange encompassing furious activity at the atomic and molecular levels. There is always motion in real systems. Some, however minute, residual springiness in tension materials, as well as ever-present invisible bustling activity on the atomic scale. We cannot see the energetic motion in most systems, and so our perception is that of a state of perfect equilibrium. And indeed, for all practical purposes, that is, for a given level of resolution, we can have a stable balance. But Fuller cannot, in good conscience, leave it at that. He reminds us that the real equilibrium would mean an end to all, or universal death. An end to aberrations and imperfections is an end to motion and energy. All physical reality, life and non-life alike, consist only of energy. Hence, there is no absolute equilibrium.
Wow.
And
that's cold. That's like taking a cold shower.
Yeah, but it fits very well with my understanding of equilibrium that I got out of chaos theory.
Yeah.
And the way they described it, absolute equilibrium was like death. And they called it ultimate equilibrium, or they also called it real equilibrium. But that meant they flatline a heart monitor. You're dead.
Yeah.
And then they had other degrees of equilibrium where you were in a pendulum sort of swing where you could swing out and back, but you would always come back to the center place. And I always, my analogy of that was somebody living on a fixed income. And you had a certain amount of flexibility, but you always came back to the fact that that's all you had that you could spend in that month. And you couldn't have any kind of an emergency. And so you were on this sort of fixed, sort of rigid system. Then the next one was what was called they called it, I forget the attractor was what they called a periodic attractor. And that's when you had a system that was controlled by a central authority. And they dictated what your boundaries were. And so if they gave you flexible boundaries, then you could live with sort of a dictator if you want, or a central control. If they gave you very narrow boundaries, then it was really hard to live inside that inflexibility. And then you get to what they call the strange attractor. And that was when you got into what they called far from equilibrium. And far from equilibrium was characteristic of motion, so that you could stretch out into, absolute energy and I'm going to solve the world today kind of energy. And then you could fold back into needing 24 hours of rest and don't bug me, just let me, let me go off to my desert island, or let me go into my room, shut the door and leave me alone. And far from equilibrium meant you've got this stretch and fold that allows this kind of give and take in life. And that
Yeah.
supposedly is the ideal.
And
Uh,
everything you just said and everything we just read reinforces the idea that the word balance is a disgusting word.
Yeah, actually, I was thinking that the whole time, actually,
yeah,
Yeah.
how the word balance has actually been used here, even
It's
this.
just it's heresy. It's heresy.
yeah,
And human beings
Well,
love heresy. We live in
yeah,
it. We just we don't want reality. We want ice cream.
yeah, yeah. Uh, no, it's such a. And then the other one that I saw when I was reading some different literature on basically death and dying, and what it was is basically saying if you're in that far from equilibrium state and your body is healthy and all that kind of stuff, and then it starts to deteriorate, and it goes all the way down to the ultimate death. But at the same time, the mind may still be very active, or it could actually activate for the first time in its life and become fulfilled, become fulsome. Um, and so, as you go to physical death, you could end up being um, uh,
Enlightened.
enlightened in terms of the mind,
Yes.
and so someone who is, yeah, that kind of thing.
Yeah.
And so someone who is going with you towards death, they're upset because
They
they're,
see the
they're going to lose sort of a physical
something.
being.
Right.
Um, but if they saw it the other way, they could also see the fulfillment that was coming out of
Absolutely.
the experience of dying.
That's exactly what this book is all about, the advice on dying and living a better life by the Dalai Lama. Are you arguing against assisted suicide? Seems like a pretty good argument
hmm.
Uh, no, I'm uh,
because
I'm
that
not
is my,
arguing against it in one sense. Another is
yeah,
one is the euphemism of assisted suicide is medical assistance in dying,
right.
um, and the reality is, I don't care um, how it's assisted. If if I give you permission to give me the drug,
Yeah,
it's assisted dying or assisted suicide because that's what I want to do. I want to die.
right, right.
If you give me the pill and I have to take it myself, that's
Aha,
still assisted dying.
that's right.
Um, and uh, my counterpoint is that if we're going to have made medical assistance in dying or that kind of assisted suicide, then we need to have a parallel, what I call now suicide safer assistance in living, SAIL.
Yeah, agreed.
Uh, and that if somebody is going through the experience of MAID, or at least they want the 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 right to be medically assisted, then they need to also go through a process of whether or not sale might also be an option.
Right.
Um, and because people who are dying very often uh, want want to leave because of a pain situation,
Right.
and those who want to take their own life are doing it for the same reason. It could be a different pain, it may not be
That's
physical
right.
pain.
Right.
Uh, so the two are experiencing the same degree of pain, if you want, that says I
Right.
want out of here.
Right.
um, and so I'm saying it's like a double bag. Um, yes, we can help you die, just like hospice and all that sort of thing, but we can also help you live. And so now you've got more than one choice.
And this book is about how to get the most out of dying.
Yeah,
If you're going to die, die consciously. Um, my only reservation with medical assisted termination is the fact that there is that process going on in a human being where even though they're totally physically paralyzed, something's going on. And it could be all sorts of recalibration. It could be all sorts of things. And it would seem to me that, of course, it's karma. If I get Buddhist about it, if I kill myself, I'm going to be reincarnated with the same freaking desire and maybe come out like the snake that eats itself. Uh, you know, so I'm not clear on it. And I'm certainly, if somebody chooses to do that, I think volition, a person ought to know if they're supposed to die or if dying is the route to go. But I just think it's one of those things that just can't be known, and there's this chance there's some enlightenment that may come before that last experience of pain. So,
yeah,
you
and
know,
there's an issue of autonomy in there. I love the both the
yeah,
movie and the play that was around years ago, but it's called Whose Life Is It?
uh,
And it's a the whole play and or the movie is all about somebody who's paralyzed from the neck down,
yeah,
and he's saying that um, he wants to die, and everybody, all the medical people and everything around him is trying to convince him all the reasons why he's still got a life that's worth living. Um,
yeah,
and so the eventual, um, I think, uh, end of the play is that I think he's gone to court, and the court has actually said he has the right to decide,
yeah,
and the play ends.
yeah,
And so now you don't know whether he exercised that right
or not.
or all he wanted in the first place was just the right.
And
Uh,
I can say that a person, I mean, volition is a sacred thing, and I can say that a person doesn't have the right to choose to die. But then I look at Jesus. I mean, he could have made another choice and decided not to get on that cross. You
yeah,
know, if I'm a mystic, I could say he could have called down angels and rained hell on everybody who wanted to
yeah,
torture him. But if I was just a realistic politician, I'd say he could have left town. He didn't
yeah,
have to go into the court of Pilate and say, "You said it," right?
right. Oh
He didn't
yeah,
have to do all that. It was volition. It was assisted
yeah.
termination. I don't want to say suicide.
Well, I'm in conversation with a person right now who was in the military in a fairly sensitive sort of role, combat, if you want, kind of role. And
Yeah,
so the being explained that we were given cyanide pills
yeah,
that if we were ever captured,
yeah.
we could protect our love of our
Knowledge.
country,
Yeah,
and we protect our constitution uh, by ending our life.
yeah,
Um, and right now, this person is not in the military,
yeah,
doesn't have a cyanide pill, but is
yeah,
struggling. And her cyanide pill right now is the right to take her life,
yeah. Gotcha.
and she can decide to do it.
Yeah,
And where she's run into real problem is when somebody else says, we're forcibly hospitalizing you,
Yeah.
taking away that right.
Yeah. It's such a perplexing situation.
Yeah, yeah.
And there is no, I don't think there's any ultimate right answer. It's wonderful. Each person has volition and each person
Mhm.
exercises that volition, and the argument is sacred.
That's right.
It's a sacred argument. You, I can't pick a side.
We, I had the best example of that when we first did our training, suicide intervention training in California, and we were in a gold town, gold rush area of California, in a fairly small town, and one of the one of the people in the town, I'm about 10 seconds away from I'm
Dying?
being powered out. So yeah,
Okay.
dying. So if
Yeah.
I disappear, I might try and reconnect, but that's the reason. Ultimate equilibrium
That's right. It's a damnation. It's terrible.
is a machine sort of dictation. Anyway,
That's right.
I'll tell that other story some other time.
Well, we'll give you every opportunity to come back in should that happen. But do you want to complete your point?
Well, it was just that um, oh, now I've lost it.
Oh dear. I was
Uh,
saying that it's a sacred argument.
oh yeah, I know, because there was a Southern Baptist minister in the town, and he wasn't really well liked, and they all thought that he had a particular idea about whether suicide was a sin or not. And so when we got to that part of the training, everybody was waiting to pounce on him when he said, "I think it's a sin." And
Yeah.
instead, he said, "Sorry, but that's not for me to answer. That's sacred between the person and God."
God.
and and everybody just, the air was just punched right out of
Sucked out
their
of the
system.
room. Absolutely. Well, I'd like to finish this. We only have like a page left to go. So I'd like you to read until you pass out. And then, um, and then, and if you do pass out, understand that we're going to continue to just finish through
Yeah,
page 113. Okay?
right. So start where? Which one?
Right at nature, I think.
Oh yeah, nature is said to abhor an equilibrium. Yeah. Okay, we just agreed on that. So I guess we're
Right.
nature. As much as
She.
she abhors a perfect vacuum or a perfect anything, the asymmetric deviations and aberrations relative to equilibrium are inherent in the imperfection of a limited life. Despite the untenability of equilibrium, it seems to me that we could approach or employ it referentially. A comprehensive energy system could employ the positive and negative pulsations and intertransformation tendencies of equilibrium. The vector equilibrium is a condition in which nature never allows herself to tarry. The vector equilibrium itself is never found exactly symmetrical in nature's crystallography. Ever pulsive and impulsive, na nature never pauses her cycling at equilibrium. She refuses to get caught irrecoverably at the zero phase of energy. Wow. All events are, all systems exist as a result of their constant fluctuation in and out of ideal equilibrium, far too rapidly for perception. Fuller's goal was to develop a model for what the theoretical ideal must look like in terms of spatial properties. But vector equilibrium is not a structure. He is quick to point out the distinction. It is a system. This is really important to me now, this structure system difference, to be comprehensively grasped by metaphysical minds. Synergetics accommodates Heisenberg's indeterminism of mensuration inherent in the omnia symmetry of wavy linear physical pulsations in respect to the only metaphysical, ergo physically unattainable, waveless,
Sorry.
exactitude of absolute equilibrium. It is only from the vantage of eternal exactitude that metaphysical mind intuitively discovers, comprehends, and equates the kinetic integrities of physical universe's pulsative asymmetries. The concept of imperfection can only be held relative to the mind's grasp of theoretical perfection. In other words, pulsative asymmetries require a frame of reference in order to be defined and registered. Time is responsible for these asymmetries. Separate time out of the picture, separate time out of the picture, and you are left with the absolute.
Sorry. There you go.
Yeah.
Oh, maybe not. Is it the previous
Yeah.
page? There we go.
Separate time out of the picture, and you're left with the absolute perfection of timelessness. Absolute equilibrium exists subtime or metatime. The passage of the shortest instant of time will reveal pulsative asymmetries. But metaphysical mind has an all-important need for timeless models through which to understand universe.
Wow, and we finished page 113. And before your battery dies, do you want to share some takeaways? Joe, are you still here, my man? Go ahead, Richard. Why don't you share your takeaways?
I guess my my biggest takeaway has to do with this understanding of equilibrium not being static, um, and that it's always pulsating, and so it has to be the language of dynamic has to be in it to qualify that it appears to be static. The idea of work home balance, you can picture the idea of balance on the teeter-totter, but you have to appreciate the pulsation of it. And I've always used the example of if you put two little kids on a teeter-totter and get them in balance, and they sit there all day, they're never want to go back to that playground.
Yeah.
But if you get them there and they can bounce up and down and have a good time and sometimes flip one guy off and he can scrape his knee, they want to go back there every day.
Right.
They really want to be in that kind of balance.
Cool.
So that's my biggest takeaway. And this rereading this particular section of it fully confirms um, my understanding of far from equilibrium balance as the ideal balance, uh, the balance that we're all trying to experience in our day-to-day kinds of living. So that's my takeaway.
Cool. Want to pass it along?
Oh, is Joe still there? Yeah, over to
Yeah.
you, Joe.
Yeah, no, so for me, I mean it's more focusing on the interconnectedness of the spokes and actually understanding how that works. Um and how that you're minimizing energy within that framework. So you get to the idea of a minimum system. And so I thought that was an interesting way of displaying that in particular. So and then the idea of the conceptual versus the
Mm,
the actual. I thought that that was actually very important. A lot of times especially more so technologically speaking, we've mistaken the conceptual for the actual.
right.
And so I think that that is an increase in risk during the with digital types of technology. And so, I mean, I think that this is like kind of bringing us back to the more uh, tangible experience, if you will. So, which I think is really important, especially uh, in today's world. So, in the digital world in particular. So, Steve, how do you feel, and what are you taking away?
Well, I'm very excited that Richard hasn't powered out yet. That's very exciting. Um, I've had a couple epiphanies today about dimensionality. I mentioned to you that little um, saucer, the cup saucer on the two strings and how it spins in two dimensions. There's no third dimension, so the spinning is irrelevant. It's not experienceable. I also had another zap today as Richard was sharing on his takeaways that the zero vector is not zero. If it were zero, it wouldn't be present because there's internal momentum going on. And I would probably call that angular momentum if I were an outside observer. But from the inside observer, if my heart stops, my body quits, and then I go someplace else and I am not observed any longer. So that was my other little thing. I'm still convinced that and I invite you guys to check out bikes. Every time I've looked at bike wheels, those spokes do not come off at 90 degrees. And I've realized that on the one side of the wheel, they go off to the right. On the other side of the wheel, they go off to the left. That is a counter vector. If you guys look at a bike wheel, see if that's not true. And I think that that's what by going off at a 60, and I'm going to assume it's 60 degrees. I'm going to get my protractor and measure that next time I see a bike. That spoke goes off at 60 degrees this way, but on the other side, it's going 60 degrees that way. There's the tension that makes those that tensegrity that makes them happen. So I'm thrilled that we got through this tonight. We've covered some great ground. I'm so excited for everybody's experience and what you guys share here. And I'm ready for next week when we're ready, when time comes around, when we get there. I'm complete. Everybody complete?
Yeah,
Yeah.
All right.
Steve. I really do.
See y'all soon.
Vector.
Glad you made it, Richard. I mean, glad you made it, Joe. Good to have you here, man.
Great to be here.
All right. Good for you. See you soon.
Take care. Take care.
Bye-bye.
Bye.